Hey, ladies and gentlemen, once again it is me, Erisa, chipping in to solve for you some questions on probability. We have discussed in the previous lecture the combined rule, the probability rule for combined events. Now we want to see how do we make use of that rule to solve problems. But before we move on, let me remind you about what we have discussed. We said that if you have two events associated with the same experiment, okay, we have two events A and B. Okay, this is a sample space S, this is event A and this is event B. Okay, then this is the union of the two events. We have probability of A union B is the probability of A plus probability of B minus probability of A intersection B. Okay, so if you pick the whole of A, which is this part, that's where the circle covers, okay, it is covering all what is in A. Now you're gonna add on what is only here, okay, to get the union. So that's why we say probability of A, right? But on B, we subtract the intersection because what we want to do is to add the A only. So that was discussed last time. Now, there are also some important results that we came up with last time. We discovered that the probability of A intersection B is the same as the probability of B intersection A. We also say that the probability of A is the probability of A intersection B plus probability of A intersection B complement. Okay, sometimes this is read as the probability of A but not B, or it is A only. Okay, similarly, the probability of B would be probability of B intersection A plus probability of B intersecting A complement. Okay, then the other important result that we discussed last time, which we want to make use today, was the probability of A complement, neither A nor B, okay, is the same thing as the probability of A union B complement. Okay, neither A nor B is the probability of A union B complement. So these results are so important. We want to make use of them, move away from the discussions and see how they applied in their life. Let's solve a problem about this. All right, let's look at this problem. Okay, it was a printed kind of question, but some people have problems with their eyes, so I've decided to rewrite it. So it says in a group of 30 students, all study at least one of the subjects, physics and biology. So 20 attend the physics class and 21 attend the biology class. Find the probability that a student chosen at random studies both physics and biology. Okay, so this is something about the intersection, physics and biology. Now, what do we do in this case? Let's see. There are two ways of going about this problem. We can use Venn diagrams, okay, or we can use the probability rule for combined events. But let's go by the Venn diagrams, which is quite simple. So solution, we are told that this class has 30 students. So that's very simple, and it is giving us something to start with. So let's have this as the sample space. The number of the sample space must be equal to 30. Okay, so in this class, we have students taking physics. Let's use P for physics. And those taking biology, let's use B for biology. Okay, which shows that P is standing for physics. Then B stands for biology. So we are told that the number of those taking physics, they are 20. 20 attend the physics class, so these are 20. And the number of the biology class is 21. Okay, so let's let number of physics intersection biology be x. So if these are x, then here we have 20 minus x, and then this is 21 minus x. So 20 minus x study physics only, and the 21 minus x study biology only. So how do we go about that? How do we find x? We know that 20 minus x, okay, plus x plus 21 minus x, they should give us 30 students. You know, we have been told that in this class, okay, there is this statement which is so important. All the students study at least one of the subjects. So at least one means that we don't have anybody in that class who does not take physics or who does not take biology. So each of the 30 students listed at least must study one of the subjects, physics. So this is 41 plus x is equal to 30, and the x is equal to 11. Okay, so if x is equal to 11, then we can either find the probability of physics and biology. So the probability of physics intersection biology will be the number of physics intersection biology over number of the sample space, and these are 11 out of 30. Okay, we have got it. If we had used the probability rule for combined events, we would also get the same answer. Okay, so I can say alternatively. Okay, we know that in this class, the probability of physics, unfortunately I used the P for physics, so I will change just the color. The probability of physics is number of physics over number of the sample space, and we are told that 20 out of 30 attend the physics class. Okay, then the probability of biology will be equal to number of B over number of S, and these are 21 out of 30. Okay, now we know something about the probability of physics union biology. They mentioned something, okay, indirectly here. Union biology is number of physics union biology over number of the sample space. But they said each student attends takes at least. That means that nobody is outside the union. So these are 30 out of 30, which is equal to 1. So we can say that but probability of physics union biology is the probability of physics plus probability of biology minus the probability of physics intersection biology. Remember, our point of interest is to get probability of physics intersection biology. So the probability of physics intersection biology will be equal to probability of P plus probability of B minus probability of P union B. So this is 20 out of 30 plus we have 21 out of 30 minus 30 out of 30 you end up with 11 out of 30, which is the same thing like what we have done before. But I found that using Venn diagrams was a better approach than this. So let's look at the second problem. So let us look at example 2. Okay, still it was printed out, but the print is so small, so I've decided to rewrite it. For event C and D, they are giving us the probability of C as 0.7, probability of D union C is 0.9, probability of C intersection D is 0.3. Okay, they want us to find probability of D, probability of D intersection C complement, and then the rest. Okay, so from that information that we have been given, we can always find the probability of D. We know that from probability of D union C is probability of D plus probability of C minus probability of D C intersection D. Okay, so we are looking for probability of D here, and if we substitute, you'll find that this is D union C 0.9 equals to, okay, probability of D is what we are looking for, and the probability of C is 0.7, then minus the intersection C intersection D, okay, is 0.3, or I was again putting it in bracket, so minus 0.3, this is 0.3. So make you collect like terms and isolate probability of D on one side, you'll get probability of C is 0.5. Okay, probability of C equals to 0. Probability of D rather, not C. Probability of D equals to 0.5. Okay, and that's done. Then the probability next they are looking for. Okay, this was A. Then B, they're looking for probability of D complement intersection C. Okay, we know that D complement intersection C, if I'm to draw something small here for you to understand this better, this is C and this is D. Okay, then this is C, this is the sample space. So this is D complement intersection C, and here we have C intersection D. So we can get this from probability of C minus the probability of C intersection D. The probability of C is 0. From it is 0.7, it's given here, 0.7 minus 0.3, okay, leaving us with 0.4 as the right answer. So probability of C, okay, C, not D and C is 0.4, or C only is 0.4. So that is done. Then let's see what else are we talking about. So part C, they want us to solve to find the probability of D intersection C complement. That's D only. Okay, you can make use of the Venn diagram and interpret this much better. So this is D and this is C. So this is D intersection C complement, and this is D intersection C, and we are now looking for this part. So it comes from the probability of D. Probability of D is the probability of D intersection C plus probability of D intersection C complement. So we know that the probability of D we have got a 0.5. Okay, and the D intersection C is 0.3. So plus the probability of D intersection C complement. So this means that the probability of D intersection C complement is equal to 0.2. Then next we have the probability of D complement intersection C complement. Here we make use of the Morgana's rule to solve for this. So we have C and the D. Okay, this is the intersection. Okay, and outside here we have C intersecting D complement. So the probability of C complement intersection D complement is the same thing as the probability of C union D complement, and this is equal to 1 minus the probability of C union D. So what is the probability of C union D? It is given as 0.9. So this is 0.1, and we are done. Now we have been discussing probability rule for combined events and then the associated important results. So next we're going to discuss mutually exclusive events. Okay, in our next discussion that is coming ahead. So ladies and gentlemen, don't forget to subscribe and to click on the notification bell. That way, if I get more subscriptions and more views, maybe I'll be given something. But right now I'm working, I'm doing this for free. It is actually open to each and everyone. As long as you have your data, you can always access this information on YouTube. So don't forget to share this with a friend. Thank you so much.